Alright, we are now on the non-calculator portion of this exam. So we're looking at question 3 of the 2012 FRQ section. It says let f be the continuous function defined on -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function defined by g of x equaling all of this stuff. When you see an expression that looks like this, hopefully something should stand out to you. And hopefully the fact that this is the graph of f will put this problem in a better context for you. So let me see if I can't explain this a little bit better. If I integrate from 1 to x of f of t dt, I get g. So in other words, I have to integrate f to get to g, which means if I was to move backwards, I would have to then derive g to get to f. That's the second fundamental theorem of calculus, right? So I'm going to just make a little note up here that g prime is equal to f of x, okay? Which means you can also see this as f being g prime, okay? Now, before I even start this problem, I'm going to go ahead and establish that g prime is equal to f. Okay? I want to do that somewhere in this problem. That way the grader knows that I know that my statement's going to be true. Okay? All right, so first thing, it's going to ask me to find g of 2 and g of -2. Well, how do I do that? Well, g of 2 is going to be the integral from 1 to 2 of f of t dt. Well, how do I do that? Well, that's just integration right here. So I'm going to go from 1 to 2 of f. Okay? Well, that's kind of hard, right? I mean, the hardest part about this problem is actually figuring out what g of 2 is. And so before I do anything, I'm going to go ahead and get the equation of this line. I think that's going to help. So it's a little more involved than you would think. So I'm going to go ahead and say -1 minus 0 over 3 minus 1. That's going to be -1 over 2. That's my slope. And then I'm going to go and use these coordinates to say y minus 0 is equal to some kind of -1/2 x minus 1. So what I have is y equals -1/2 x plus 1/2. What happens when I plug a 2 into there? Well, if I plug a 2 into there, like the problem's asking me to do right here, I get y being -1 plus 1/2, which is -1/2. So why does that help me? It's because it gives me the coordinates of this right here. So what I do is this is now 2, comma, -1/2. And what that does is it sets me up to find the area of this triangle, since that's what I'm being asked to do. I'm being asked to integrate from 1 to 2. So this gives me this triangle here that has a base of 1 and a lower height of -1/2. Well, the area of a triangle is going to be 1/2 base times height. Well, that's going to be -1/4. So all of that was to find out that g of 2 is -1/4. Okay? Now from here, we're not done yet. We still have to find g of -2. Well, g of -2 is going to be a whole lot more because we're integrating from 1 to -2. 1 to -2. Of f of t dt. Sorry, the pen started kind of going sideways there. Okay, so how do I do that? Well, if I'm going to go ahead and do that, I'm going to get all this space right here, right? And then -2 is right here, so I'm going to try and get this triangle as well. Okay? So, let's do it. Well, I know that if I do my area here, the area of a semicircle is going to be 1/2 pi. R, in this case, is going to be 1, right? This is 1, so r squared. So 1/2 pi r squared, and this thing is negative because it's underneath the x-axis. Now, before you jump on me, because we're moving backwards, don't worry, I've already accounted for that. And so I have this area underneath the x-axis being the negative 1/2 pi r squared, and I'm going to add that to a positive triangle right here. And so what I've got here is 1/2, the base is 1, and the height in this case is 3. And so what I have is negative pi over 2 plus 3 halves. But I've got to remember that since I was moving backwards, that whole area is reversed. So you could call this negative 3 plus pi over 2, or you could have left it like that and you would have been fine. Okay, let's go ahead and find part B. It says, for each g prime of negative 3 and g double prime of negative 3, find the value or state that it does not exist. Okay, so if I wanted to find g prime of negative 3, that's like trying to find f of negative 3, because right here, up above, I already established that g prime is f, and we went through that earlier in the video. So g prime of negative 3 is equal to f of negative 3. Well, that means I just need to go to negative 3. Negative 1, negative 2, negative 3, and go up. Oops, change colors here. And that's about right there. Okay? And so what is that value? That value is 2. Okay? And then for the g double prime part, g double prime of negative 3, that's going to be f prime of negative 3. Well, what's f prime? The slope of f? That means I'm looking for the slope here. What is the slope of f at this negative 3? Well, how do I find the slope? Well, that's algebra 1 right there. So I'm going to do y2 minus y1 over x2 minus x1. So I'm looking at 3 minus 1 for starters. 3 minus 1 over negative 2 minus negative 4. Negative 2 minus negative 4. So that gives me 2 over, that becomes a plus, 2 over 2, which I get as 1. And that's part B for you. I'm going to go and clean this up so we can do part C and D. Okay, so for part C, they're saying find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative min, relative max, or neither. Justify your answers. Okay, so I think I'm going to have to go to my typing tool here for this one. Okay, so what does it mean when a function has a horizontal tangent line? Well, a function has a horizontal tangent line happens when a function's slope is 0. So, when f equals 0, whoops, can't see that. When f equals 0, a horizontal tangent line exists, right? Now, where are those places where f is 0? Remember, where f of 0, where f is 0 is going to be where f crosses the x-axis. So where does that happen? Well, that happens right here, and it happens right here. Okay, where those red x's are. X marks the spot. So that means that what we have is we can say, therefore, move this down. At x equals, looks like negative 1 and 1, a horizontal tangent line for G exists. Now the next part is asking us, are they a relative min or a relative max, or neither? Justify your answers. Okay, Now it's just chapter 5. You know, where they want you to mess up is on the second part of the answer. So we know that G has a local maximum at x equals -1, and that's because G prime, or F, goes from positive to negative there. Other variations of the answer, whoa, these are connected. I'll move them both at the same time. Other iterations of the answer could have been the graph of f crosses the x-axis from positive to negative. There are many, many ways to explain that. All right, what about at x equals 1, though? We could say at x equals 1, G has neither a max nor a min because G prime, or F, does not change sign. And there you go. That's how you do part C. Let's go and label that. All right, let's end off with part D. Part D is another explanation problem. It says, between 4 and 3, find all values for x at which G has a point of inflection. Explain your reasoning. Well, let's take a look at the graph of f, which is G prime. If I'm going to find points of inflection, I need G double prime or f prime, right? So what I want to pay attention to is the slope, the trajectory of this graph. And I want to see if and when and where this graph's slope begins to change direction. Well, that only happens a couple of times. It happens right here, it happens right here, and it happens right here. And I know there's a lot of stuff going on in this graph, but try to pay attention to the sky blue. All right? The slope of f is changing direction at the -2, 0, and at 1, and that's why we have points of inflection there. So let's go and answer that. So we can say that G has points of inflection at x equals, let's go back to those coordinates again, -2, 0, and 1. -2, 0, and 1, because the slope of f changes sign there. You could also have said because, other examples could have been because G double prime changes sign there. You could have said because f prime changes sign there. Okay. All right, so pretty straightforward problem with number 3. All right, one of these graph type deals. All right, we'll see you in the next one.